Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little more speed, distance and time with the Batty Boffin. In earlier videos we've introduced these things called distance time graphs, which show the distance from your starting point against the time of your journey. And here I've got one with 3 distinct chunks to it. On earlier graphs we've looked at these and we saw what the different parts of a distance time graph means. A straight line, you remember, indicates a steady speed. We've got a steep section, a kind of flat section and a kind of in-between section. The steeper the graph, the faster you're going, and the flatter the graph shows you're going slowly. A completely horizontal part of the graph means you're not going anywhere at all. If the graph is horizontal, it means your distance is staying the same while time carries on, which means you're not going anywhere. Now on these 3 sections here, you're going somewhere but at different speeds, and we're going to use our distance time graph to work out those speeds. Now my graph is only drawn quite roughly here. As you can see, my lines aren't particularly straight. So in the second half, when you work them out, I'm going to put on some animations that are actually accurately drawn and you can work them out from those. But this is just to show you how it's done. Now, if you remember from some earlier ones, speed, distance and time are related by a formula triangle. So here's a little revision for you. Pause the video and could you write down that triangle please? Right, it should look like this. Speed is equal to distance divided by time. So you should have a triangle that looks like this. There. So in order to calculate speed, we're going to do distance divided by time. So we're going to take just one chunk of our diagram here. I'm going to start off with this lower chunk and we'll find the distance that we travelled. I'm going to take this chunk here. I'm going to make it into a little triangle. It's a right angle triangle here. And the height of the triangle, in this case, is 30. We started off at 0 and we went up to 30. I really should have a 0 on there, shouldn't I? Excuse me just a minute. Do beg your pardon, graphs should all have the 0 on them. So on this bit, part of the journey, I've travelled from 0 metres to 30 metres, so we have a height of 30. And the width of the triangle is from 0 to 15. So in 15 seconds. I mean, I think you can probably work out the answer here, but we'll just do it anyway. So for this bit here, the speed, or velocity, because we're just talking about going in one direction. Velocity is the same thing as speed, but it's got direction associated with it. In here, we're just kind of walking down a straight path, so there's no directions involved. So speed is the distance, which is 30, divided by the time, which is 15. Pretty easy there. 2, and the units are metres per second. 2 metres per second. Okay? Second bit up here. Now we haven't got an axis on here, so we'll draw our own little triangle in there. The height of the triangle is from 30 up to 60, so that's another 30 metres. But the width this time is different, from 15 across to 20, so that's just 5 seconds. Okay, pause the video and work out the speed for that please. You should have this. The speed is distance over time, which is 6 metres per second. Now on this last bit here, we've got a much flatter section. Here we've got 10 metres in height from 60 to 70, and we go from 20 out to 35. So from 20 to 35, that's 15 seconds. That's for that section. That's for that section. What about for this section? Could you work that out, please? Okay, slightly more tricky numbers this time. Speed is the distance divided by the time. 10 divided by 15, not 15 divided by 10. 1.5 is not the answer. Okay, 10 divided by 15. Any thoughts on that? Well, you can, if you're not sure about doing those kind of divisions, just simply grab your trusty calculator. Okay, so we go 10 divided by 15. You're going to get a 0 point, yes, because it's divided by a bigger number. So we've got 2/3, which kind of we knew that anyway, didn't we? Yep, 10 over 15 is equal to 2/3, which your calculator should give you 0.666666666, which I'm going to write as 0.6 recurring. That little dot means keep going with the sixes. 0.6 meters per second, which is right because that's quite a lot smaller than this. If this was 2, that shouldn't be 1.5 because it's quite a lot smaller. Okay, so that's 0.6. We've got 2 meters per second, 6 meters per second, and 0.6 meters per second. Okay, right, I'm going to wipe down the board, and then instead of doing another board of stuff for you to do, you're actually going to get some animated stuff, and I'm going to have a go at doing whizzy voiceover bits. So pop back in the second half, and there'll be some for you to try. See you in a minute. Right, here you can see my beautiful graphic of a distance up the side and time along the bottom. Distance is marked in meters, time is marked in seconds. And you can see I've got some bits of line drawn on here. I've got the grid lines drawn, so that makes it easier for you to count them. And I'd like you to look at section A, please, the part of the line marked section A. And what I'm going to ask you to do is simply work out the speed that is. Remember, the speed is the slope of the line. Speed is distance divided by time. So what you're going to need to do is work out where the triangle goes, calculate the height of it, which is the distance, and the width of it, which is the time. Divide the two and get the speed. Okay, your turn to have a go at that one. Welcome back. How did you get on? Here's the height, and here's the width. And when we divide them, here's the speed. Did you get that? Great. Could you have a go at section B and section C now, please? Let's work through those together. For section B, here is the distance. Please note it's not just the top number, it's the difference between the bottom of the line and the top of that line for section B. So you need the height of the triangle. It's the distance covered in that section. And the time that you took to cover that distance is given by the width of the triangle. And again, distance divided by time, here's your answer. Don't forget the units. And for section C, it's the same. Here's the distance, here's the time, and here's the speed. Now, just when you thought you had finished, could you please work out the overall time for the entire journey? So we're doing an average here, okay? So you need a huge triangle going from right at the beginning to right to the end, the entire distance, the entire time, and work out the average. Okay, off you go. So here it is. Here's the whole distance and the whole time and the average speed. Now you will note that if you take the average of those 3 speeds that we calculated for section A, section B and section C, if we take the average of those 3 speeds, we do not end up with the average speed. Okay, you can't just average 3 speeds and get the average speed because you don't know how long you've been doing them for. Section A, you'll see, is a lot larger than section C. So that means the section A speed has got more weight in it. So if you're asked to do an average speed, please don't do the average of the speeds of the sections. You need to work out the total distance and the total time and then do the speed from that. Okay, I'll see you in the next video, Batty fans, when we're going to be looking at velocity time graphs. So I'll see you then. Bye for now.